I just spent 90 minutes on one single algebra problem and I could not solve it. Do you understand what I'm saying? Let me just repeat that to you. I spent an hour and a half on a problem in a subject that is taught to 8th graders, and I could not solve it. Do you understand what I'm saying to you? I took calculus in high school. I took AP calculus, A, B, and BC. I got an A in one and a B in the other. And I could not solve an 8th grade algebra problem. Let me explain what it is. You have two neighbor fractions. A neighbor fraction is like 1/2 and 1/3. 1/3 and 1/4, I think, are neighboring fractions. The mathematical rule for them is that when you subtract one from the other, you have to get 1 over whatever the two denominators are multiplied together. So 1/2 and 1/3 are neighbor fractions because 1/2 minus 1/3 is 1/6. 2 times 3 is 6. So you have 6 in the denominator, which is the two denominators multiplied together, and then 1 in the numerator, 1/6. It can also be -1. So 1/3 minus 1/2 is -1/6. So that also counts. I believe it has to be both ways. So the problem was, given that A over B and C over D are neighbor fractions, prove that A plus B over C plus D, prove that A plus C over B plus D, so the numerators added together over the denominators added together, prove that that number is in between A over B and C over D. I spent 90 minutes just trying to reallocate numbers and fool around with equations and move numbers together, move variables around. And I could not crack this shit. It is baffling. And it has brought me to the conclusion that algebra can and perhaps is often harder than calculus. And if you ask me, I would say that the only reason you take calculus after algebra is simply that you need to know algebra in order to do calculus. If you ask me, that's pretty much the only reason. And most of the problems they give you in high school algebra, I will admit, and middle school algebra, whatever, are fairly trivial. They give you easy ones, but algebra can scale. It seems way more than calculus can scale, although I could be wrong, but this problem is way, way harder than any algebra problem I've ever tried to solve in my life, in any class. It's out of a textbook by this guy named Gelfand. The entire textbook, you know how most textbooks are usually like 1,000 pages? This one is 150. And you might be thinking, oh, it's 150, it must be fairly trivial. No, there's a reason why. It's dense. It took me like an average of probably an hour per page so far to get through to like page 35. It is the most dense textbook I've ever read in my life, but it is reassuring because I feel like once I'm finished this shit, I will never need to pick up an algebra textbook again. I will be a master of the craft. And I'm really excited to get to that point because then I can do the same thing for perhaps geometry and then trigonometry and then calculus, and then I can move on to applied mathematics such as physics, astrophysics, quantum physics, engineering, mechanical engineering, aerospace engineering, computer engineering. I am incredibly excited to learn more about all of these fields. I find them all so interesting, and I love all of them probably equally. And this will probably take me a really long time, but I don't know. I don't really care, because it's about the process. I find it so exhilarating. The progress, when I feel like I'm getting better, that's what really gets me going. The old adage that it is about the climb, not the destination, or whatever the fuck they say. So what I'm going to do about this problem is I'm going to very basically sleep on it. There's a large misconception that is, I feel, is often held, that growth in any subject happens while you're doing the thing. And I would argue very much against that, because the principles of neuroplasticity in the brain, I don't have any sources for this shit, don't ask me to give you sources, I don't have time for that, but the principles of neuroplasticity seem to dictate that, yes, the stimulus for growth happens while you're doing the thing, but then the growth itself takes place during the off time, both while you're awake and while you are sleeping. You've probably experienced a situation where you were really stuck on a problem, and then you went to sleep or took a walk or something, and then you kind of figured it out without having to think about it more. This is because the brain needs time away from the problem so that it can strengthen connections, I believe via synapses, if I'm not mistaken, to build the mental map of the situation. So maybe not most people, but a lot of people might tell you that you should sleep less, and I'll sleep when I'm dead. And they use that to say, if you sleep less, then you have more time during the day to do stuff, so you'll have more practice in whatever you're doing and you'll get better. I used to think this myself, but I don't think so anymore. I would say you need both equally. It's kind of the same way with weightlifting for muscle growth and strength gains. The stimulus comes from the lift, from the workout, but if you just work out all day for 12 hours straight, you're not gonna grow. You will over fatigue your muscles, and if you sleep 5 hours that night, there's gonna be no recovery. You bring the muscle close to failure so that the muscles tear, and then when they recover, they build back a little bit bigger or a little bit stronger, or both. It seems that the same goes for mental growth and growth in a certain skill that requires cognitive work. It seems like the same thing is the case. So that's what I'm going to do. And based on prior experience, I should wake up tomorrow or whenever I decide to come back to this problem with a different outlook on it and a better understanding of it, and I might solve it. So we'll see what happens. I got a homemade Chipotle bowl that I dipped up for dinner tonight. I'm about to watch some Family Guy. I've been on a Family Guy kick the past couple days. I'm really fucking excited. This bev right here is not wine, contrary to what you may think. It is pomegranate juice.